In this lesson, we will learn to create a convenient way to group variables together. Consider this data entry form. We have the first and last name of an employee, years of service, and contract type. To capture and later use these values in our code, we may start off by declaring them as separate variables and assigning values to each one of them from the worksheet cells. Now, this approach is fine, but it may get cluttered later on, especially if you're writing long code that uses many more variables. Notice in our code here, the variables for the values captured from the employee details form don't particularly stand out from the ones that we're using to store calculated values. And as the code increases, we will need to keep reverting back to these assignment statements to keep track of the original form value variables. And as a solution, we could simply group these variables together. These form value variables have a common theme. They have been captured from the same form, but a more logical commonality would be that they are all employee related records. So we can group the variables based on that. Here, we have created a group of variables called type employee record. And now we can access each of these variables individually through that group. This group is called a user defined type, or a UDT for short. And in this next code, we can now easily distinguish between form value variables and calculated variables. But this differentiation is not the only benefit of using UDTs. Let's learn more about them. In the following sections, we will learn how to first create a user-defined type and then look at several use cases. If you're following this course linearly, then I must state that we are about to cover some intermediate topics such as arrays and functions, which we haven't introduced yet in this course. You can always listen in now and bookmark this lesson to refer back to later. A variable is a convenient way to refer to and temporarily hold data. The value stored within a variable falls under different categories called types. Common types are integers, strings, dates, and booleans. In VBA, it is possible to assemble different data types together to create a single data structure called a user-defined type, or UDT. UDTs are a data type derived from other data types. They can hold multiple values. Each value can be of a different data type. They are lightweight, at least when compared to classes. They make our code more organized and readable. Let's start off by creating a user-defined type. We can declare a UDT using a type statement. We will place the type statement at the top of the module above all procedures. UDTs by default have a public scope. If we want to restrict access to just the current module, we could use the private keyword. And if we want them to be accessible project-wide, we could use the public keyword. UDTs are public by default, and we don't need to mention it explicitly. Let's give this type a name. Standard naming convention rules apply. We will call it type employee record. Let's close out this type statement first. Now, a UDT is simply a combination of other variables that we'll now call elements. Let's declare one element. We want to capture this first name from the form, which will be a string. Declaring UDT elements is similar to regular variables, except that we are not going to use the dim keyword. And we mentioned that UDTs are a group of variables or elements. So let's add some more. We'll capture the last name as well. The elements within a UDT don't all need to be of the same data type. So let's declare an element of the long type and another as a boolean type. Great, and that's our UDT. We could even declare an object type within this UDT. We'll see an example of this later on. We can even nest UDTs, that is, declare an UDT within another UDT. We'll see an example of this as well later on. But one significant drawback is that a UDT cannot contain functions. If we want to add functions or methods, we would need to create a class within a separate class module. However, if all we are after is a simple structure that holds similarly themed variables, then UDT is a better lightweight option than classes. Okay, let's move on to using this UDT within our code. Create a sub. Think of a user-defined type as just any other data type. To use it, we have to declare a variable as this UDT that we have defined above. We can just start typing the initial characters, and that's our UDT, tab, enter. And now we can assign values to each of its element. To access the first name element, we will start by providing the name of the UDT variable. Dot. We can see the list of members, choose the first name, use the equal to sign to assign the value from the worksheet intro. In this lesson, we're going to use the worksheet code names directly. So WS intro. And we'll populate the rest of the members. An alternative way to populate multiple members of a UDT variable would be to use the with statement. So with the variable name, close the with. And now we can use IntelliSense to access each member variable. Press dot. We see the member list, select the first name and assign it the range value. We'll just copy it over from up here and we'll do the same for the rest. And let's just delete this off. Next, let's extract the stored value from each of these UDT elements. We will print out the values using the debug.print statement. But first though, let's just add some logic to make our code more practical. This isPermanent variable is a boolean. We will create another string variable called employment. If the isPermanent variable value is true, we will assign the string value permanent to the employment variable and contracted otherwise. So if the employment is permanent, then we assign the value permanent, else it will be contracted. Okay, let's make some space. Okay, now let's print out a single sentence that contains all the members of the UDT. The desired output will be as follows. I'll just leave the statement in here for reference while we build out our code. We can start by printing out the value of the first name member element concatenated with the last name. And note here, we will treat each element according to its declared type within the UDT. Both first name and last name are string types, and we can join them directly with more text. So let's add some more text. We will continue on to a new line within our code. So ampersand and underscore. Next, we want the years value, which is a long, and we can join it directly to a string. VBA will implicitly convert this number to a string in the background. However, just to highlight the differences between each member element, let's explicitly convert the value of the long to a string using a string conversion function. And add some more text. We'll join the employment variable that we have derived from this isPermanent boolean variable. And add some more text. Okay, let's print the text. Great, our statement gets printed. Next, let's look at nested UDTs where we declare a member variable of a UDT as another UDT. We will stay with this previous example. Right now, we are dealing with these 4 employee record fields, which is manageable, and hence we have grouped them directly within one UDT. But imagine a larger form with say 50 fields. In such a situation, we may want to further divide the fields into subgroups. For example, we have this first name and last name, which can logically be grouped into their own UDT, which we can call name details. And since we're going to nest this name details type within this type employee record, the name details type needs to be defined prior to this employee record or within a different module. we'll declare two members called first and last. And now let's come down to this original UDT. Instead of first name and last name as strings, we can declare a new variable. Let's call it employee name as the name details data type. Next, let's assign values to this new type member. We'll come down to our assignment statements. Instead of employee.firstname, we'll go dot employee name dot and first. And we'll do the same for last name. So this is the member first within the employee name type that has been declared within this employee variable, which is of the type employee record. And now let's come down to the print statement and update the variable names. Run the macro, we get the same result. One advantage of creating UDTs based on the smallest divisible group is that we can reuse these UDTs. So let's come to our form, and what we'll do is add in two more fields. Okay, so we've added the manager first name and the manager last name, and we can reuse the name details UDT to capture these two new name values. So we'll come to our original UDT and add in manager name as a name details type. We'll read the values from the sheet. So choose manager name dot first and do the same for the last name. And let's print out these values as well. We'll just modify the statement. Okay, run the macro, and the manager name gets printed out as well. Great. So these were basic ways to use the user-defined types. What we'll cover next is slightly more advanced topics from the sense that we haven't covered arrays and functions yet within this course. So in this last example, we built a group of variables called a UDT. However, we still treated each member variable independently. That is, we individually interacted with each member within our code. However, we can access this full group of variables together as a single variable. So let's look at one use case of the scenario where we pass a UDT as an argument within a function procedure. Let's declare a UDT with the members first name, last name, and email ID. Create a sub. Declare a variable as this type and assign string literals to the first and last name. Now let's build out the email address of the employee based on the first and last name. We will first build out this logic within our current sub. And take note, we're going to assign a value to a member of the UDT based on the previous two values. And just for reference, we want the final email ID to look something like this. So join the first name to a dot, and then to the last name, and then to the server and domain name. Okay, print out the email ID. Run the macro. We get a result. Now let's perform this concatenation within a separate function. Probably we'll just rename this sub to display, and we'll call a function build email ID. This function will accept a parameter as this user-defined type, and the function will return back an email ID, which is a string. So let's just copy this logic down below and update the variable names. And now assign the output of this concatenation back to the function. And now let's call this function from our main sub. Comment out the previous logic. Call the function and pass the new employee variable as the argument. And that's it. Let's run the code and we get a result. And that was how to pass a user-defined type as a parameter within a function. But we are not done yet. In this particular example, we don't actually need to use the function. The default passing mechanism for variables when using procedures is by ref. And we can explicitly mention it here as well. So use the by ref keyword. When we use by ref, we pass a pointer to the original variable. And any changes made to this variable within any other procedure will affect the original variable as well. So here, we're trying to create a new email address and return the value via a function back to the email ID element. Another way to achieve the same result would be to assign the value directly to the email ID within this procedure. So let's just make a copy of this function, comment it out. Okay, so now we don't need this function to return any value, which means it can simply be a sub where we assign the value of this concatenation directly to the email ID element. And now for this logic to take effect, we need to call this sub from our main sub. So instead of assigning the value, we can just call the sub. We still need to pass in the type as an argument. And this will effectively update the email ID for us. And that's it. Remove the result. Run the macro. We get our email ID. And just FYI, we can't pass a UDT variable using the by val mechanism. If we did so, we would get a compile error. And one more thing, this example provides a good distinction between UDTs and classes. Since a UDT can't contain its own method, we need to explicitly create a function or a sub to create the email address, and then we need to explicitly call that function or sub for the value to be assigned to the UDT variable. When using classes though, we could create a method to build this email address within the class itself and call it whenever the email ID property is read. What this means is that our code within this module would look a lot simpler, but we don't need to dive into classes any further. Next, let's look at a function that returns a user-defined type and see how that's useful. One common issue with a function is that when the return value is declared as a basic data type, such as a string or number, we can return only a single value. This places a restriction on the scope of operations you can perform within a function. Sure, we can return multiple values using an array or a dictionary. However, accessing those return values from the array or dictionary is less intuitive than when using a user-defined type. Let's look at an example. We'll declare an email ID as a constant. Our goal will be to split the email ID into the first name and the last name. Let's define a type with two string variables for the first and last name. And let's add a Boolean variable called success as well. Its purpose will be to validate whether we were able to successfully split the email ID into its components. Create a function. Pass the email ID as a parameter. And this time, we will declare the return value as a user-defined type, which will be the one we have defined above. We will perform two splits using the split function, once on the @ symbol and the other on the dot symbol. So let's declare two arrays to hold the results of each split function. Perform the first split. So we'll split the email ID and the delimiter will be the @sign. Let's perform one validation. If there is no symbol in the email ID, that means that the email ID is invalid and we should exit the function. In this scenario, the split function won't return any elements, and this both names array will have an upper bound of 0. So if the upper bound is 0, then we will indicate a failure by assigning false to the success member of the UDT variable. The name of the UDT variable is the function itself. Assign the value false and exit the function. But if there is an symbol, we will move on and indicate a success which will be equal to true. Perform the second split on the dot symbol. And what will we perform the split on? We'll perform the split on the first element that has been stored in this both names array and give the delimiter as the dot sign. Now, there is the possibility that the dot is missing between the first and last name components. However, to keep this code short, we won't perform any more checks. So the single names array will have two elements. The first one at index 0 will be the first name, and the next one will be the last name. We can assign both these values to the respective UDT members. And that is our function. Let's look at what we have achieved out here. First, we are returning two string values back. This itself is a step over a traditional function which would return only one value unless we used an array. But in an array, we need to read the elements by providing the index numbers. So like this, which is less intuitive than presenting the value as a UDT member, which would look like this. And further, we are even performing a validation check within this function. In the functionality of a traditional function, we would need to perform the validations and the split operations in two different functions. One which would return a false if the email ID is invalid, and the second which would return the split values. But we are able to perform this entire operation within the same function. And this is possible because of UDTs. And on a side note, whether or not performing two distinct operations within the same function is good coding practice or not is a completely different conversation. Okay, so now let's call this function, create a sub, declare a variable as the UDT, call the function and assign the full return value set back to the employee variable. We'll pass in the email ID. And if the split within this function was successful, then we will print the employee first name and last name. And else, we will print an error message. Okay, let's run this code. We get the first and last name. Now let's remove this symbol, run the code again, and we get an error message. Great. Next, let's try and add an object variable to a UDT. An object variable is simply another variable. The only thing to note is that we have to follow the rules of an object variable, such as using the set keyword when assigning an object reference to it. Consider the following scenario. On this sheet here, we have a list of customers with some outstanding amounts. We want to sort these customers into two sheets. If the outstanding amount is greater than 20,000, then we will copy that customer details over to the alert sheet. And otherwise, we will copy the details onto the watch list sheet. And the object variable we are going to add to the UDT will represent the worksheet object. We shall see that doing so will allow us to create a single logic to address copying data onto both sheets. And note that the watch list sheet and the alert sheet already have a header row. Let's go to our VBA editor, declare a constant for the threshold value of 20,000. Define a UDT to hold the customer details. And another variable to refer to the worksheet. Let's create the sorting procedure. Declare a variable as the outstanding type. Declare some iteration variables for our loop. Clear the contents from the second row down in the alert and watchlist sheet. Let's loop over the data from the second row to the last row of the data range. Assign the worksheet values to the type members representing the customer details. If the amount is over the threshold limit, then we will assign the alert worksheet reference to the sort sheet member of the UDT variable, and note the use of the keyword set. And else we will assign the reference to the watchlist worksheet. Let's make some space here. Okay, come out of the if statement. Now we can create a generic logic that will address either of the worksheets based on whichever one has been assigned within the if statement. Let's find the last available row on the worksheet to paste our data. And the worksheet is represented by the sort sheet member variable. To find the last available row, we'll do an int excel up to find the last used row and then add 1 to it. And let's transfer the data onto the worksheet. So the data in column 1 will be the customer name, and in column 2 it'll be the amount. Okay, that's it. Let's run our macro. Go back to Excel. This is our data sheet. There are two values greater than 20,000. Go to the alert sheet. We can see those two customers out here. And there are two values less than 20,000. Go to the watchlist sheet. And we can see two customers out here as well. The notable points here are how we use an object variable within a UDT. Without a UDT, we would either have had to create a separate function to handle the pasting logic, or we would have had to create the same logic twice for each of the data and watchlist worksheets. Next, let's check out how to declare an array as a user-defined type. Why to define an array as a user-defined type? The main advantage would be efficiency. And another advantage would be that we could fit different data types within the same array. To achieve the same result in another way, we would need to declare an array as a variant which consumes more memory and runs the risk of bad type conversions. In other words, declaring an array as a UDT preserves type safety. And besides that, code readability is always in the favor of a UDT. Okay, so let's look at a scenario similar to the previous one. We have the same data set of outstanding customers. We want to transfer just the ones above the threshold over to the alerts worksheet, but this time we will take a different approach. What we will do is load up the relevant data into a UDT defined array and then output that data onto the alerts worksheet. The main objective of this exercise is not to explore the most efficient way to transfer data, but rather to learn how to use an array of a user defined type. Okay, let's start with the basics. Declare the threshold. Define the UDT. create a sub, create a variable to count the number of rows in the data set. Next, we need to find the number of rows in the data set where the threshold is greater than 20,000. This will tell us the size of the array that we need to create. We can find this number using a COUNTIF function. Okay, so our arguments are we are counting the number of rows in the column B and the filter criteria is greater than 20,000. Now, let's declare an array as the outstanding type. Now for an important point, when using a UDT, we can't declare the size within the initial declaration using a variable. If we try to do so, we will get a compile error. To get around that, we can declare the array again using the readm statement, and this time around, we can provide the size. So readm 1 to the count of a criteria as outstanding. And notice we are forcing the index of the array to start from 1. Let's declare variables to hold the custom data from the data sheet. This time we won't declare separate variables. We can just reuse our outstanding UDT. Declare two iteration variables, one for the loop and one for the array. Assign 1 to the array count variable. Let's loop over a data set. First, we'll read the values from the data set. Make some space. If the amount is greater than the threshold, then we will add the customer details to the array. So here's the array. The current index position of the array will be the rCount variable. And first we'll populate the customer name, which will equal to the customer name that we have grabbed from the cell. Do the same thing for the amount. And once we have populated both the members, we can increase the rCount by 1 to go to the next index number in the array. And we'll assign it back to the rCount variable. Okay, so that's it for the loop. Now let's clear the contents in the alert sheet. To output the data, we need to loop over the array again and paste each element value line by line. So we need to loop over the alert customers array. Make some more space. Let's place the data into the alert sheet. I will represent the current index position, which will start from 1, but the row number on the alert sheet will start from 2 because row number 1 will be the header. So we will add 1 to I and bring up the value of the current cell and assign it the customer name from our array, which will be from the current element of the array, which is at index I, and bring up the customer name. Do the same for amount. It's column B and assign it the amount. And that's it. The alert sheet is blank. Let's run our code. Looks like we're getting an error, which is originating inside one of the arguments in the COUNTIF function. Let's just stop the procedure. So we can't assign the range directly. We need to provide the object hierarchy for it as well. So it is in the data worksheet within the range object. Close it. Okay, let's try again. The macro ran. Let's go and check in the alerts worksheet. And we have 2 customers, each with the outstanding amount greater than 20,000. Great. And one note before we end this topic. While we can use UDTs within arrays, we can't use them within dictionary objects and collection objects. So for example, if you want to group more than one value within the item of a dictionary, we would need to use a class instead of a UDT. Okay, that's it for user-defined types. A user-defined type or UDT can combine multiple data types into a single type. We can access members of a UDT individually. This improves code readability. We can even access the entire group of variables together as a single variable. This opens up many possibilities. We can pass a UDT variable as an argument into a function. We can even return multiple values from a function using a UDT. UDTs are more lightweight than using a class. However, unlike a class, they can't contain methods or functions. UDTs can be used within arrays, but not within dictionaries and collections. If the objective is simply to use a bunch of variables as a single group, choose UDT over a class. And that concludes the overall topic of variables and data types. From the next lesson on, we will begin the topic of control structures, which will include if statements and for loops.